Because you said you want us to make a video for the slide, right?
Yes, it would be really, really great.
So I'm just trying to upload it to YouTube. Is that the best way to make the video, is to upload it to YouTube?
So after the video,
Yeah, it's echoing.
it's fun.
Oh, did you say something? I think you're muted now.
Do you hear now?
Yep, I can hear now.
Okay, so yes, it's really great to upload to YouTube if the video has been generated. So you need to check if the code that you are using does have a module to create video. So can you show the commands that create video in your code?
So in this one?
Yes.
Would it be lowered?
No, your code does not have these commands. So you need to insert them. Do you remember presentation of Nate on this subject?
It's been a while, but I think I remember the broad view of it.
So it should be three portions of the text. So somewhere at the end, you need to open file where you save movies. In the middle of the loop, you do get frame command, and at the end, after the loop, you close the file. So like
Okay.
open, get frame, and close. And I'm not able to recall exact syntaxes of these commands. So we can borrow and copy paste from someone else. Or you can wait until others will show. So, but tell me what are your restrictions in time, and I'll try to cooperate. So you need to go somewhere?
Yeah, I have something to do in a little bit, so I can only be here for like half an hour.
Okay. So let me find out something on this computer, and I'll probably make a little demonstration. But you should try to look through your records from previous labs. We went over it again and again several times. I'll try to explain it as new, but maybe you will find things quicker. Okay, I'm going to share screen. You didn't found it yet?
No, I have not.
Okay. So let me continue. So here is the code by Joshua. Takes too long to bring it up. Okay, I have the same code here. So there are several commands, and you need to have them in your code.
Okay.
So 3 blocks. I will copy paste it to the chat line. At least I'll try. So first block is open file. Okay. Then second block is get frame. So capture frame. And the third block is close the file. So
Okay.
you do need to insert it into your code and then rerun it. So let me stop sharing, and you can start. You can try sharing again.
All right. So would it go in the middle?
Before, did you insert the opening file before loop?
Would it go like right here?
Yeah. Here is okay. Okay.
And then should I change? I should probably change
You
this.
can change it to whatever you like. Instead of call it after your name or after your project, or it doesn't matter. Okay, now let's scroll and close to the end of the loop. Scroll here before pause, copy paste the second thing.
Okay, I gotta open that back up. Hold on. I need to stop sharing so I can see the. I don't know why I couldn't see the chat. And then put that after pause, right?
Yes, or before pause. It's not critical. Before the command end that that ends the loop. So inside the loop. And you can start sharing so that I observe what, if you like.
All right. So I put that right there. Is that okay?
Okay. Yes. And then after this command end, right here, copy paste the third thing. Basically, let me. You can just type close. Oh yes. Okay. That's it. Now save and run and see what happens. Does it typically go long? How long does it go?
It usually is done like right now.
Okay. Now it goes a little longer because saving image into movie delays it a little bit.
Yeah, it wants to go a while right now. So then I was just gonna insert, should I just do a video for both my positive and negative value for each of these?
Yes,
Okay.
and then it will save your time on explaining, because if you try to explain what is going on with words, it will
Yeah,
be
that
long.
might be a little.
Okay. Now, after
There we go.
everything, after it is done, if you type, let me request control if you agree. So in the command line, you can check what are the files, and you have coded die something.
Yeah, dye sensitized.
Okay, so you have this die sensitized. Now let's try to upload it to YouTube and see what happens.
Okay.
So yeah, open the browser, go to your, okay. So you were doing the movies, you know how to do it.
Yep, I do. I was just gonna make sure because when I just forgot to add those 3 steps to the code before to make sure that it was dye sensitized.
Yeah, scroll down for telling
Oh,
it's
there it
not,
goes.
not
Yeah.
for kids. For next, next, next. Make it public. Publish. And
Yeah, I think it just needs to.
yeah, you can close. You can close here.
And then I'll just make another one of those.
You can do it later.
Yeah, I'll do that later.
So if you use this connection, you see how it runs, and 24 seconds could be out of, yeah, it works.
Yep.
The best thing is to insert this movie into your PowerPoint. And inserting link is not always quick, so optimal. If you upload to YouTube and then download the sensitized MP4 MP4, can you please bring the slide where you want the movie?
I will just open.
Just a new slide. You okay.
I'll just insert a new slide and then we can put it in there.
Okay, yes, thank you. Insert movie from file.
I think it was downloads.
And something starting with the letter D. Right?
Yep. There it is.
So this one will be a little smaller and more reliable because it was already frozen. And then you can just explain what you see during your presentation and loop until stopped, so that it doesn't stop in the middle of your story. Okay, and then do the same for your other thing.
For the other one, yep.
Okay, anything else?
No, I think that's it.
Okay, yeah, thank you. Now,
thank you.
Oh, my pleasure, I like it. You can stop sharing and feel free to stay connected or disconnect as your schedule allows. So Adam, would you like to share screen?
Yeah, sure. Give me a second.
Mm-hmm.
Can you see?
Yes.
All right. I have a kind of a very rough outline. There are still figures. I need to add figures and then more detailed explanation, but something of a skeleton should help me guide me.
Okay.
What do you think of the format? Should I change anything? Should I take out certain sections? Because these are supposed to be like section headers. Multiple slides can be made on individual ones.
Eight slides. Well, I don't know the content, but what personally I'm looking for known theory. So you know my preferences. I'm hungry for equations and explanations what they mean.
Yeah.
Equations and movies.
Right. Yeah. I will be including the movie in the simulation, and I should be providing equations in terms of the rate with the rocket notation as you mentioned. I should be defining most of my parameters, or like most of the thing in the known and the theory, and maybe stragglers will be addressed in the parameters if there's anything I need to clear up a bit more. But I plan to make the equations in Word because I find it very difficult to do in PowerPoint. But maybe I can port some of the equations over from that I already have printed.
Exactly. It is the plan. I never assumed you will be retyping them. It's copy pasting from the paper. Yes.
Yeah.
It's standard. It's what is expected. Otherwise, what's the reason to write a paper? Only to steal from yourself and use your own pre-made things. Okay. Please administer your own time to have a couple of personal practice talks for yourself, because with 9 slides, you can immediately unleash yourself to 2 hours of presentation, which your colleagues will be not happy with.
Yeah, I'll definitely try to not make it that long.
So 4 minutes is ideal, but if it is like 5 or 6 minutes, it's like permitted, but still
4 minutes.
Well, 4 minutes is an unreachable goal, but like last year's probably the longest went up to 7 minutes. But if everyone makes 7 times 9 plus there will be questions, we can be in danger. So briefness is the sister of talent.
Yeah, I'll practice making it and be sure to portion out adequate time for the slides that need to be touched on, like the movie and the equations and stuff.
Right. And let me share a trick I practiced during my doctoral defense, and then it was working out through the life for me and for other colleagues. When you have your slides ready and you realize they would take more time than necessary, you may create a provocation. So keep some designer questions that looks missing in your talk, and make a slide that answers this question, but do not show it until you get questions and answers section. So
that's a good idea.
Have some glowing open questions that will look like you do not know or you are hiding. Then the audience will take this hook, and then you show, oh, sure, here is the slide explaining all details.
It's a good idea. Thank you.
And it will save time. Then you formally will fit within time, but on a note of answering questions, you can use more time than is typically permitted for an average speaker.
Okay. When I talk about the methods, should I be more specific than I am in the publication, like or in the I'm not in the publication, but in the paper.
I would be, my heart would melt if I see it, but on the other hand, time limit is really hard. You cannot explain much. So let's set up the following style of thinking. You do have your main result, right?
Yeah.
And you have interpretation. And now if we roll your paper, if you read it backwards, if you see main result and its interpretation and your glorious conclusions, but then which evidences are needed to prove that your result is correct? Like what is shown on the main figure? What is the definition of your, what you are showing rate? Then it is very natural question. Where is equation for the rate? Both through Marcus and through your calculations. So
Yeah.
even if you didn't have it in the paper, now it is time to add it. And it is even more important than anything else. And then if you write down an equation for the rate, which will be like, well, you can show when it is ready, and I'll be happy to provide feedback. There will be several terms in this equation. And when you look through them, next question is, what is the definition of these terms for the rate? And then you unwind things backwards, skipping unnecessary details, but show main steps needed to obtain your results.
Okay.
Make sense?
Yeah. I have a question about the rate thing. So obviously I have this this
Yes.
formula.
Yes,
So
but it is Marcus already got credit for his rate equation.
Okay.
What is the rate that you are computing for the broken glass data in your last figure?
It's the rates of charge transfer in I guess within some bounds, like I don't have the words.
So I think we are bringing you out of your comfort zone.
Yes, yeah. But it's the rate of charge transfer in the bounds of the experiment. So that would be constrained by time. That would be that would also be determined by the extent of resonance between eigenstate or wave functions and the eigenstates.
Okay, so wait a second. You're trying to mix together two things. First, how it was computed, and second, how you interpret it. So I have no problems with interpretation.
Okay.
But I have, well, I wouldn't say problems, but if I want to be rigorous and picky to your work, then I do not see definition of how the rates were computed.
Okay.
So let's scroll through your. Where's the main? So rate K, how these orange dots were obtained, where this data comes from.
Yeah, it's an average, right? It's just an average.
What we need equation for each orange dot.
Okay, sure.
And I think some of other class attendees are trying to do it. So just tell me in a lay language, not as a like thing for record, where these dots are coming from. How did you compute them? I remember you did it yourself, so you should be able to explain.
How did I compute the rates?
Yes. Where orange dots came from?
Just variation in the offset energy.
No. X-axis, energy offset.
Yeah.
Is your input. And the y-axis, how tall, how high these orange dots are, where these values of rates came from.
thought that what you had in the code, I thought that what was in the code was kind of an analog of this. I looked over
Yes,
it.
exactly. And I'm with you. I feel that it's out of your comfort zone. But just by rules of game, it should be not something similar. We need something exactly telling how the code is working and expressing it in form of equations.
Okay. Oh, that makes sense.
So I remember about 2 weeks ago, you were showing like a PowerPoint slide with 20 slides, each of which was showing results of dynamics for specific value of energy offset.
Yeah.
Can you bring it up?
Sure. Yeah. Do that.
So let's scroll through it. So, and please guide me, where did you, okay, so you probably, oh yeah, enough. This figure is good. So at the result of each simulation, you are getting, do you see my cursor?
Yeah.
So you see this yield of reaction, you see probability of transfer as function of time.
Yeah.
So the question, how do you extract rate of reaction out of this curvature, out of this probability of transfer?
Wouldn't it just be like derivative?
Yes. So let's just make a record. So you take the slope, right?
Yeah.
So we have the probability of acceptor at time t2 minus probability for occupation of acceptor at time t1, we divided by t2 minus t1, and we call it rate.
Oh, okay.
So this is equation, and these results are obtained again and again for each value of this offset.
Yeah.
So
The time steps are made in dx, right?
yes.
Okay. So each individual step would be t1, t2, up to t, I guess, sub the value of dx. Yeah.
Okay, so you think you agree with this equation, and you can type it in and present, right?
Yeah. Yeah.
Okay, excellent. This removes one barrier, one difficulty. Now, how the P sub A was computed at each time step?
Yeah. Yeah, God, isn't that from the I'm blanking on this. It isn't that, doesn't that have to do with our email conversation?
It is related, but
Yeah.
we never wrote this equation together. Maybe you wrote it alone and didn't share with me, but we still need an equation for this P sub A. Or maybe we did, I don't remember. Let's do it. So let's, can you bring up your paper?
Yeah, sure. Actually download it. Okay.
Okay, maybe scroll. Okay, so the most important part is here. And if I see, maybe you better operate your computer. Just copy this equation.
I got it.
Thank you. And
Oh. Edit. There. Okay, right here.
yeah, okay. Check if I can type. At each step of the dynamics. Now please paste this equation once again. As it, yeah, this one.
Didn't copy. Okay. There it is.
Okay, and now we at each step of the dynamics, instead of 0, we have t, right?
Yeah.
Then a probability that system is in the donor state is, there is a longer way to express it, but I'm just a little lazy and impatient. Can you please copy this psi sub d?
Oh yeah. The entire term?
No, without d, just psi sub d until
Okay.
the bracket, until
Yeah.
the bracket.
Oh, it's a bracket.
And yes,
Yeah, I got it.
copy and paste into the next line. Next line. Next
Like
line.
here? Gotcha.
Yes. Okay. Or wait. Okay, in the equation mode. Come on. I'm just a little lazy. It should, instead of x1, x2, it should be like x maximal, x minimal, or from minus to plus infinity, whatever, dx. And it's not the whole story. I'm going to type this absolute. I'll fix it in a second. Absolute value squared. This we don't need. And this one. Can you please copy once again this psi sub d, or and move it into yes, and remove it after this at the end of the line. Okay, now let's copy last two lines, copy and paste them after. Okay, thank you. here we don't need this letter P. A probability that system is in the acceptor state is, and then we just replace D with A.
Yeah.
So this equation is critically important. It's quite simple, but it is important for understanding, and it deals with our today's lecture. So this red, bra, and cat, D and A, are electronic states, right?
Yes.
And instead of simply time-dependent wave function coefficients, we do have vibrational wave function.
Yeah.
So it serves two ways. First, it is amplitude of probability that system is either in donor or acceptor. And second, it is actual wave function at which position in space this probability is higher. So let's please ask any questions about these equations.
I don't have any questions right now.
So you agree with them, or you hate them, and you just do not want to think about them?
No, they. I mean, I agree with them. It should help me patch some holes that I have right now.
Okay, and then by processing the change of probability of acceptor over time, you just get the rate, how quickly the probability jumps or flows from donor to acceptor, right?
Yeah. So the difference in these two integrals over change in time.
Just derivative of P sub A over time. So the slope of this curve, let's come back to your. So this one is, this is P sub A. And the top one is P sub D.
Oh.
So at the beginning,
yeah.
there is 100% on donor and 0% on acceptor. And as time goes by, it goes from donor to acceptor. But at each point of time, P donor plus P acceptor equals how many?
No, 100%. Like
Yeah.
a 1.
Yeah, exactly. And if it goes up linearly, you just take a slope and it will be your rate of the reaction.
Okay.
So I think this is a main part, and now I think your work is logically consistent. By the way, this blue and orange stripes are, let's go back to the paper. They are this absolute value of psi d squared and psi a squared.
Yeah, that makes sense.
They can be plotted separately. So acceptor is orange, and originally it is not very vivid. And as time goes by, it appears a little more pronounced.
Yeah.
Okay. So now initiative is yours. What else you think is missing, or what else you want to clarify, or?
So this I'm just trying to think. So the compute, like the simulation, the MATLAB script itself, does it take at each step of dx? Does it take this slope and then average them at the end?
Yes.
Yes. Okay. Okay. That's what I have here. Okay. Okay, good, because I just wanted to make sure that it wasn't just, you know, one particular slope of these um, uh, at one particular point, because I would have missed the purpose. Okay, all right, that makes sense.
One can dig deeper and discuss most efficient way to extract the rate out of the P sub A dynamics, but those are technical details.
Yeah.
Right now, we just want to have correct principles.
Yeah. Okay.
So in my plans, you are candidate to be the first speaker.
Oh, okay.
So just first speaker typically gets more questions. So try to get ready.
Yeah. I'll use the trick you told me about. I'll prepare additional slides after, just to conserve time, but to be able to answer questions graphically, if need be.
Okay. Okay. So do you see any other questions?
Not at the moment. No, I can email you if I think of any.
Okay, yeah, you're welcome to stay connected or disconnect. Or you probably can, if you want, you can work on your slides while we are talking to Joshua, and after we are done with him, I'll check if you have more questions.
Okay, sure.
Or if you need to depart, you're also like free man in a free country.
Yeah, I need to go pretty soon.
Okay, so you can stop sharing, and I look forward to hearing back from you more. Joshua, would you like to share a screen?
Sorry, that was mute there. So, all right. So here's the video that you sent me.
Uh-huh.
Yeah, I'm just still a bit confused how you made it work.
No, I just ran. I didn't change anything in the code. I ran absolutely the same code you sent to me. So we can try to repeat it on your computer. So if you
all right, and then just draws all these figures.
Okay.
Yeah.
And I need command window.
On command window. All right. Yeah. Okay. So there you go.
Yeah, it's very good, very good. So that we see both command window and the code. Yeah, I like this arrangement. So you were, let me request your permission to type something on your computer.
Right.
Yeah, thank you. So it looks like you were running the P echo, right?
Yeah.
And right after, oh, just a second, ls.m module.m. Okay, so right after you run the photon echo, you have variables that include the projections of spin, and you just need to visualize them. In the code, the this one module movie block, we can even open it. I can do it this way. Open. So what it does, it just scrolls through the results of the scroll through results of the SX, SY, SZ, right? Through all time steps. And at each time step, it does save the frame into the video object.
Yep.
So we need to run this module movie block right after. Now it asks you to press any key.
Yep.
And now on my computer, it was running for about 20 minutes. So it's quite, you need patience. I don't know if you missed to run this second code, or you were just stopping it because your patience expired. But on my like, it may run even longer, maybe for an hour to collect this movie. And you see, it doesn't give any errors. It's just slowly going through, and we can discuss.
Oh, I see a little bit of motion.
Okay.
It's moving very slowly.
Right, right. Because there are many time steps.
Yeah.
And then after you see confirmation that this thing does work, you may decide to rerun the p-echo code with different parameters, and after rerun the module movie block to create another movie. So
All right.
do straight different runs with different movies. Okay, your computer is quite quick. It was slower on mine.
I mean, it's starting to speed up a little. It's just slow at the beginning.
Mm-hmm.
And since my paper was pretty much about changing the number of like molecules in the ensemble, I might try changing that parameter and see how the speed of this movie changes.
Yes, it would be interesting. It would be interesting. So while it is running, we can discuss something else and maybe go over your paper. Just bring it up.
All right. Yeah, right here. Yeah.
So what I'm mostly no. Oh yeah.
Okay.
So I'm mostly worrying about the how comfortable are you with this equations 5 a to d. How do we have connection to spin projections? And if no, we need to, oh yes, there is a connection. So I want you to explain maybe equations 10 and 11 first, and then maybe return back to equation 5. So just tell me what you think about them, and later on we'll I'll adjust if needed.
All right.
So let's start from equation 11.
Okay, okay, sorry, it's just that the Zoom screen is sort of getting in the way there, so.
But I see it clearly, so.
Yep. All right, so now that I move the screen, I can see it clearly.
Mm-hmm.
Okay, so as I mentioned right in this paragraph, that's pretty much for the spin, and also mentioned about the average spin in the ensemble.
Right. So when you do have different number of molecules or different number of spins in the ensemble, so you did it like for 4, what else? 4, 10, and 20, or which numbers did you use?
Yeah, I think I used 3, 4, and 10.
Okay, so your 3, 4, and 10 are this K max. So in different runs, you have different K max.
Yep.
Make sense?
Yep.
So it is, this formula is average over ensemble. And then after average, you have this 3 components, Sx, Sy, Sz, and you are making movie how they move on the surface and in under the surface of block sphere. Make sense?
Yep.
Okay. Now let's go. So you're good on this. Let's go to this equations 10. How this individual spins relate to elements of density matrix.
Okay, so I think the X, Y, and Z represent direction, and then with the 0, 1, 1, 0, that it looks like it's something to do with matrix. So here you have like the element in 0, 1, for example, with the X, K there. You have the 0, 1, and then K there, and then plus the 1, 0, K, and I'll divide by 2. And if I remember correctly, I might be wrong here, but I think this, well, let's say P might be a Greek letter that I just can't think about the name of. But I think that's supposed to be the spin density.
So yeah, you're telling everything correct. So K is again the index of the spin in the ensemble, right?
Yes.
Okay, and the definition of the connection. Let me draw something. You can later remove my drawings. So if we have S plus and S minus divided by 2, so creation and annihilation operator, they are giving the Sx. Do you remember it from lectures?
I'm trying to recall. I definitely remember seeing it. Just
So it is an analog
yep.
of the definition of the X position operator for harmonic oscillator as creation plus annihilation operator divided by 2. And there are some factors like square root, mass, frequency. We don't care about factors right now. So here is the little plus.
Yep.
Here is divided by 2. And typically if we have the operators and density metrics, the operators are parsing right elements from density metrics. Like if the Sx operator from here, it will be 0, 1, 1, 0, everything multiplied by 1/2. So if we want to find expectation value of this operator, and then we multiply it by elements of density matrix, 0, 0, 0, 1, row 1, 0, row 1, 1. So when we multiply matrix of an operator by density matrix, it parses. So this element parses only this one, and this element parses only this element of density matrix, and they both come to SX projection.
Yeah.
And similar story for SY and SZ. So if we know density matrix, we can find spin projections. Okay, now let's scroll to here. Whew. So what do you think about this set of equations? I know it looks a little big and busy, but what should we focus our attention at? How would you just analyze this equation if you have to?
I mean, so it looks, sorry, just trying to think there, but notice that is like here you have like the derivative of the spin density, but it's in terms of time.
Right. So one important thing that those are time derivatives.
Yeah.
So they predict how the density changes over time.
Yeah.
Yes, correct. Another thing that these 4 equations are all for fixed value of for fixed element of the ensemble. If you take another element of ensemble, the dynamics will be a little bit different. So on the right part, the index K should appear once again somewhere. Do you see it?
Yep, it's the
Here,
omega
right?
K. There.
And there.
Yep.
So the what is this delta omega? What do you think it controls?
Isn't that like the angular momentum?
No. The generally letter omega is used for angular frequency, but here
Yep.
it is frequency of the rotations of SX, SY, rotation of the Bloch vector around the equatorial plane. So let me check if you remember a figure like this. The x-axis is B, and y-axis is energy, and then we have energy of state with spin up, and lower one is energy of state with spin down. Do you remember a figure like this?
I thought I saw something similar to that in one of the lecture slides.
Okay, so magnetic field induces split of energy for spin up and spin down states, right?
Yep.
But if the molecule is in the vicinity of other molecules, they may collide with it, they may locally change magnetic field, and therefore for different molecules, this splitting will be slightly different. There could be a little less, or there could be a little more. So, for example, this is k equals 1, and the red one is could be k equals 2. K equals 2. So the difference in this purple and red arrows could be told as delta omega, maybe times h bar. So it is how much the energies of the this spin state differ if you go from one ensemble element to another ensemble element. Does that make sense?
Yep.
And this difference in frequencies is responsible for the fact that different elements of ensemble have slightly different evolution, and then as a result they give this interference for free induction decay and later constructive for spin echo. So this delta omega is change in the splitting, energy splitting in magnetic field. Okay, what else we have here? So there is an interesting observation that you may like. So if you look from top to the bottom, you have 0, 0, 1, 0, 0, 1, 1, 1, correct?
Yeah.
And if you go from left to the right, you have 0, 0, 0, 1, 1, 0, 1, 1.
Yeah.
So change in time of the element 0, 0 depends on all other 4 with some coefficient, some of which are negligible. And the same pattern is for the rest of equations. So it's like matrix 4 by 4. The meaning of this omega Rabi corresponds to how quickly the population jumps from ground to excited if the system is irradiated by radio frequency, by changing time-dependent electromagnetic field during the pulses. So we have two constants in this equation. One, so this delta omega tells how quickly the Bloch arrow rotates in horizontal plane, and the Rabi tells how quickly it rotates in this opposite plane from top to the bottom. Make sense? Okay. So I think I'm talking too much, but if you have general idea about these equations, it is your choice to show them right away or not. Maybe you can prepare slide with these equations, but show them only if someone asks.
Right.
And then try to explain, because if you show no equations, there will be question. And if you have no explanation, it will be not as good impression. But if you will show them on the if they will be ready on the hidden slide, then someone in the audience will ask you, how did you compute this dynamics of spin? And you show, oh, sure, here are equations. Okay, I'm talking too much. Let's please take initiative and ask questions yourself, or if there are no questions, we can inspect how generation of movie is going forward.
Yeah, I don't have any questions right at the current moment. But in case if I do end up having questions after this lab session, then I might just send you an email.
Oh, sure, please. I like getting emails, and you are very welcome to send me a draft of your PowerPoint earlier. Like if you send me it to me this night, I will go over and look and provide you feedback so that you can improve it.
All right.
Also, I wanted to ask, and I maybe asked Allison, but she was not enthusiastic enough. Do you think you would like to see PowerPoint slides from previous years?
Yes.
Okay.
I would love to see like some examples.
Okay. Yeah. For you, it will be one of the slides from Steven, but I can send many slides for others, and then they will compare what they did and what was done in previous years.
Yeah.
Let's inspect how your MATLAB code is progressing. Did it finish by now? Let's bring up command window.
Yeah.
Let's look on the command window because it will indicate whether code has finished. No, it's still busy.
Yeah.
It's still running. Do you have two versions of MATLAB simultaneously?
Apparently so. I mean, one of them is full screen, the other is half screen.
Yeah, do not change anything right now so that you do not stop healthy working code. But in the future, since it is only a small personal computer, it's better to have only one version running at a time. If you run MATLAB on a supercomputer, then it's fine. One can do several versions in parallel.
Yeah, I think probably one of them just accidentally opened up. I was trying to open up MATLAB. Maybe sometimes it happens if I do it in extra click.
Okay, okay. So I hope very much it works, and I really want to see that success of this run. So do you have more questions, or you? Oh no.
Yeah, I'm good for now.
Okay, so I just want to maybe watch and stay here to see until it completes. Maybe
right.
I'll check once again with Adam if he has more questions, and if you can stop sharing, and I'll ask Adam. Adam, how things are going?
Yeah, good. I have a question.
Please do.
Okay, let me share my screen if that's okay. Okay. I'm gonna zoom in. So, could this also be?
No. It should be both, either only donor or only acceptor.
Yeah. So I was gonna
okay,
like A minus, right?
Why minus?
So this is. Oh, I mean, sorry, A minus over here and then A.
I would put only A because it is the same variable, like X and Y. Your function,
yeah, sorry.
Y, it's just a label.
Ah. Yeah. Oh, okay, that makes sense. I don't know why I was thinking. I was just thinking, I guess the probability, but it would make, it would make more sense. I would think correctly. Yeah, thank you.
So,
That's all I needed.
Okay. Let me give a quick comment. So some people, let me request draw, request control. So we are using here, we just agreed to use this like PA and PD, right?
Yeah.
But some people use alternative notation and they call first state P donor acceptor, meaning they both are neutral.
Hmm.
And second one, P donor acceptor, where donor
Yep.
lost electron and acceptor got an electron.
Yeah. Can I use that?
Whatever you find comfortable. And I think your boss wanted to attend the meeting, so you can think of project his style of thinking and what he would like at most.
Yeah.
Feel free to use it.
I plan to show this on the same slide as this.
Mhm.
Just it'd be helpful to see, since I have I guess this notation, it'd be helpful, I think,
Mhm.
to see this form.
Mhm.
So this would just be used in the same way, right?
Yes, yes, they are like interchangeable.
Okay.
Just you choose one and then keep it across your work consistently.
Yeah.
Just
Yeah.
do not jump from one notation to another back and forth.
Right. Yeah. Okay.
Yeah, and sorry for making marks on your Word document. I do not know how to delete them.
No, it's okay. No worries.
Okay.
This is useful to me. Yeah, that was basically the only question that I had.
Okay. Yeah. Yeah. Thank you. Thank you for supporting discussion. If you want, you can stop sharing, and I'll check with Joshua. Joshua, you can start sharing and just satisfy my curiosity if your code has completed. We're still busy.
I think it's probably still.
Yeah, but it came to the most wait, this one is not busy anymore. Okay, okay. Yeah,
Okay.
let me. Maybe we are already done. Let's check. Yes. What's the name for the code? Block movie. Okay. And what is going on with the second copy of method? This was. So both are done. I don't know which one is more correct. So let's check if the file block movie 2 mp4 AVI is not empty. So we can either try to open it with your with this player, or maybe just right away try to upload the movie into YouTube. The meaning is that YouTube has some codecs and some tools to process video which are better quality than we have on our equipment. So maybe open the browser. Try to go to YouTube.
YouTube. All right.
Huh?
And you go create,
Yes.
upload. Just setting it to load there.
Okay, and now let's select files and identify.
Oh, I do see the block moving.
Okay,
Yep.
let's move forward. Hope it is not empty. sorry, playlist. No, it's not made for kids. Next, next, next. I don't think you want to make it a secret. And publish. So if it is processing, we can close. And it should be done shortly.
Yep, it is.
Okay. Open in a new tab. So if it goes through it, yeah, it moves. It moves a little slower than we wanted to, but it does work.
Yep.
I personally I'm using Mac, but I think the PC also should have the video editor, some basic video editor. Are you aware of how one runs video editing on PC? Or not sure.
No.
So there should be. Let's keep oh, you can do like to yourself. Oh, you can. Okay.
I was just trying to move the Zoom screen. Is sometimes as I move it out of the way to see one thing, but then when I go to another screen and I'm blocking part of it, I want to see, so I need to move it out of the way yet again. And yet, since you have control, I can't really do much.
So Adam suggests that there should be Windows Movie Maker. Can you find it? Maybe typing movie.
There's a video editor.
Yeah, some video editor. Adam, is it the one that you suggest?
Oh yeah, they must have changed it at the update.
Okay, and before we go forward, there is another trick. In the YouTube, one can download back the movie that you have uploaded, and after that it becomes showing folder. It becomes a little thinner. It optimizes and make the movie more compact. And now if you go into your movie editor.
Right. All right, so I have to go down.
Yeah, you better do it.
That's photos.
Okay.
Yeah, but it says photos, but it's here.
Maybe immediately import.
Import. Right. From a folder.
Okay. Maybe downloads.
Downloads.
No. We should identify where this recently downloaded things went. We'll figure it out. We'll figure it out. Let's cancel and maybe new video project is the right way. Okay. Project variant here. Yeah, from this PC. And maybe this.
What was that?
Yeah.
Okay.
This would be good. This would be good. And let's see which one of them is thinner. Yeah, block movie.
Hold on.
This one is.
Hold on, they start sharing. Yeah.
But when you are ready, you can start sharing again. And this is not a scientific thing. This is just way to make the movie to play quicker.
Yeah, sorry about that. And wasn't sure what was going on there with YouTube, but
Oh, sometimes YouTube starts playing things that we do not want to play.
yeah. Yeah, my bad. I apologize.
No, not a problem, not a problem.
All right, so should I try sharing the screen again?
Okay, please.
All right.
No, we don't.
All right.
So
And
it's-
go back to the editor.
Yes. So we need only one of them. So uncheck the rest. Keep first.
You keep the first here. I think the one here is just a copy of that.
No, I'm not sure.
Or is this? So
uh,
here it says 634. Here it says 639.
maybe the latest one would be better. Yes.
Yep. All right. Open.
Okay, and now I would try to pull this from top to the bottom, just drag and drop. Okay, and now it shows that it is 3 minutes 59 seconds. And there should be an option to save it, and there should be an option to to change the speed.
Oh,
Adam, do you,
there's-
if you,
yep.
oh, okay, speed,
Yes, speed.
make it quicker. So set clip speed, once again, speed, and
I
there should
can't see.
be, let's maybe, yeah, move it a little bit, move the whole thing, and maybe expand the screen.
Yeah.
Okay.
Speed. There we go.
Yes, fast. Not about 10 times faster. Or yeah.
No, it's 2002 for 816. So probably
Okay.
8.
Okay, whatever you select. And now,
But
yes.
then would put it back
So
30
29.
seconds.
So let's run and see how it looks. Better?
Yep.
Okay. Now it stalls for time, and then sometimes later it will come back. So now the radius is short, and about now it will start growing. No, it doesn't grow.
No.
And did it grow in the original movie?
I mean, with the one file movie that you sent me, it did.
Hmm. Okay. Well, you can use this one as a backup to insert it, but if you have energy, you can try maybe running code once again and see if it reappears. But let's look how one can save it, because I never worked with this movie editor. There should be a button to like publish movie or save or maybe export file. So if you click on the this project, and now there should be an option to something like save or publish. Adam, do you have an idea? Did you try it in the past?
Let's see. Try the, you see like the pencil or whatever in the upper left by new video.
Yeah,
You try that.
that's the name of your video.
Oh, finish video. Yeah,
Finish video?
yeah. That should do it.
Okay.
Okay.
And exports.
Uh-huh. And
And
then
here,
select,
probably go downloads.
okay.
I might want to change the name. Just thinking about a good name for the video though.
Free induction decay
Okay.
or spin decay, whatever.
All right. Exports.
Uh-huh. Okay. So even if it doesn't give this revival, at least it shows how the length of average spin vector decreases. So it's
Yep.
also interesting effect. So you can now let's practice how you can. Well, of course, one can publish it on YouTube, but in addition, you should be able to insert it into your PowerPoint. So can you bring up your PowerPoint slide and try to insert video? Insert. There should be video. Maybe media.
It's your video.
Okay.
Download and then free indefinite decay.
Okay. And let's check if it plays. Okay, it does. It's good. So you know how to do it. And just in case if you are speaking about it and it stops, one can loop until stopped. And then even if you speak longer than 30 seconds
Yep.
on it, it will continue rolling again and again.
All right.
Okay, I'm very happy. I'm very happy for your success and making sure that all of you guys can include videos into your presentations was my goal for today.
All right.
Well, if you have more questions, feel free to ask.
Nope.
No?
Don't have any questions for now.
Okay, yeah. Then send whenever your slides are ready. I'll be happy to glance over. Adam, do you have any questions, or Adam has already left?
Yeah, I think Adam has already left, so I guess it's just us two.
Pardon me?
Yeah, never mind. I think I'm the only one left, so
Oh, okay.
yeah. Don't know if there's anyone else in the classroom.
No. I think everyone else knows how to make videos, or they don't care.
Yeah.
Okay. Well, then I suggest we just announce the adjourn and finish the meeting.
All right.
So, yeah, thank you for your efforts, and I look forward to see your slides and very curious to hear your talk on Friday.
All right. Thank you.
Thank you. Have a good night.
You too.
Yeah, thank you.